Hey guys, so today I want to show you how you can use a solar generator and a transfer switch to back up your house when the power goes out. OUPES has just released what might be their best power station to date. It's the OUPES Guardian 6000, and here are some of the main features. It has 6,000 watts of continuous output, so you can run a lot of stuff in your house at the same time. It has 4,600 watt hours of lithium iron phosphate batteries. You can cycle those 4,000 times, which is every day for about 10 years, and it'll still have 80% of its life. It'll take up to 2,100 watts of solar input. It'll take 1,800 watts off of a 120 volt AC outlet, or it'll take 3,600 watts off of a 240 volt AC outlet. Now this is their first unit that outputs 120 or 240 volt split phase, dual voltage unit. It comes with just about every standard plug you'd ever need already on the system. It has a 6-year warranty, and best of all, if you get it before Christmas, it's on sale for $1,700. And if you get it before the end of the year, you could qualify for the 30% tax credit and get it for $1,200. So I really like to thank OUPES for sending me one of these units for testing. Now let's look at how we're going to connect it to the house. Okay, so you've got your power station, but do you really want to be running through the house pulling extension cords in the dark? I don't think so. So that's why I'm going to use the Reliance ProTran 2 transfer switch. It's a kit. It comes with everything you see here. It was $300 on Amazon. That's the regular price I paid. I didn't get it on sale. The main piece is the 30 amp 6 circuit switch here. They also make a 50 amp 10 circuit version of this, but I've got the 6 version. It gives me 6 circuits in my house that I can back up. And they all have the breakers. Everything's included. That's the main piece. We also have a plug. That's how the power comes in, 30 amp plug. And we've got a 30 amp 10-foot cord. All this stuff is included. We're going to use this to bring all that OUPES power, 6,000 watts, into our main circuits of our house directly through the main panel. Got everything we need? Let's get started. Okay, so the way this works is we've got utility power coming in from one side, and we've got solar power coming in from the other side. Now this switch right here represents one of the circuits in your house. Let's say this is the refrigerator. If the switch is in the down position, then it's using utility. If you push it up to the top position, now it's running off the solar. In the middle would be off. So basically it's that simple. You have a 3-position switch, you have a box that's powered by utility and solar, and you're just telling it, I want you to run off the utility, or I want you to run off the solar. That's about it. It comes with 4 of the circuits set for 120 volts and 15 amp breakers. You see these are all individual switches here. Now notice this one is tied together with a bar. It's just 2 individual switches that are connected with a bar, so they switch at the same time. That's a 240 circuit, right? And here's the 240 breaker, that's a 20 amp. Now the first thing you're going to do is go over to your panel and you're going to figure out what are the 6 most important things in your house that you want to back up. That's all up to you to decide. Of course, you're probably going to want your refrigerator as the most important thing, and then pick 5 others, right? In my case, this house doesn't need any 240 circuits backed up. They'd rather have other things that are singles. So you can take this bar right here and you can just screw this right out, and that'll make these 2 singles again. And then I'll take this breaker, this double pole out, and replace it with 2 of these 15 amp singles, like so, and just rewire that up. So that gives me 6 individuals once that's out. Now notice that this switch, it currently has 15s in it, but these 4 circuits can run up to 20 amps, so I could take this breaker out and put in a 20 amp breaker if I need to. Here, 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 and here. And then the first 2 slots have a little bit bigger wire on them, so you can put up to 30 amp breakers in the first 2. But keep in mind, the entire box is only rated for 30 amps, so you can't just, go over 30 amps. All right, so here's our main panel, and I went ahead and marked all the circuits we're interested in with blue tape. Got a refrigerator, microwave, plugs and lights. Now I could have done some 240 circuits like the pool pump or the dryer, but in an emergency I'm not that concerned with those two things, so I'd rather have these other circuits. Now if you're on a well, you're going to want to put that on one of the 240 circuits because you definitely need water. Now I do plan to use the car charger. If we got enough solar panels, we could charge the car in emergency when all the gas stations are empty. But I don't have to burn up one of my circuits for that because this OUPES has so many plug options. I got a 1450 right here. That's the same plug on the Tesla charger, so I just take it out of here, drop it right down onto the OUPES directly. Same thing for this guy. This is our internet, right? It's plugged in right here. I'm not going to burn up a circuit for that. I can just drop it right down, plug it in. So I'm getting more than just the 6 circuits here. I'm getting a lot more. Anyways, I'm going to go ahead and pull this cover off and we'll start getting busy here. Okay, so we're going to surface mount that transfer switch just like this panel is mounted because we're on cinder block here. I'm going to mount it with a 1/4 inch Tapcon. This has got threads all the way up to the end because we're not going through anything. And then I'm going to drill it out with a hammer drill. If you're mounting to stick, like 2x4, 2x6, then you're going to cut through the sheetrock and put everything inside the wall, including the wires and everything. I did a video on that a while back. I'll link it below. So now I've got to feed all this wire through this little piece of conduit so that I can run over to the panel. Nice and easy through here so we don't cut anything. Look at that. There we go. All right, let's take a closer look. Got the transfer switch mounted. We used our Tapcons into the concrete. All the switches. Now check out all the fittings here. That's, see here, this is a sharp edge. It's really sharp, and if you don't use fittings in here, it'll chafe on the wires and you'll get a short possibly down the line. See the fittings coming out. We got our conduit. There's a plastic insert at the end because the end of the pipe is always sharp. Some burrs on there. Here it comes through. It's all nice and tight. We'll get to hooking up the wires, but first let's hook up our plug. So somewhere right about in here. Gonna mark these holes and get them drilled out. Left. So what I got here is a 30 amp 10 gauge wire. It's pretty stiff, hard to work with. They usually are in these small boxes. So it already had the ground wire on here. It grounds the lid and it grounded the box here. So I added my ground from my 30 amp hookup right onto that same thing. So that's all grounded. Now we've got the X and the Y are the two hots, the red and black. X and Y are the two legs. And then the common goes on the W, right? So now I'm gonna, close this up, crunch those wires up a little bit. Then we'll put this in conduit, run it on up into the transfer switch, and then we can hook it up inside here. So I got all my wires coming up in here. I'm going to put the ground here to the green, black to black, red to red, common to common. Got red to red. I'm going to wire nut it, and I'm going to tape it up. All right, making progress. We've got everything wired up. White to white, that's the common. The two hots, the red to red, the black to black, and then the ground onto this green ground strap. Everything's in conduit, 30 amp 10 gauge wire down to our inlet box. It's all mounted to the wall. So this part we can go ahead and put our cover back on and button that part up, and then we'll move on to the wiring. All right, now for the fun part. I'm going to go ahead and cut all of the breakers off, and then I'm going to cut the main. Everything should be off, except this is still hot up here. So I don't want to get anywhere near that stuff, but I should be able to work in here. I'll check it with the meter. Okay, the first thing I'm going to do is hook up the ground and the common. Common will go over here on the common bar, ground's going to go over here on the ground bar. Alright guys, we're ready to hook up our first circuit. Now we've got an A, B, C, D, E, F, 6 switches. Each switch has 2 wires associated with it, a red wire and a black wire. So for the A, we've got a red A and a black A, and they're all labeled. Okay. So we're going to start off, we're going to hook up this is our refrigerator. I'm going to pull that wire off there that goes to the refrigerator, and I'm going to put in the red wire from the transfer switch. That'll send power from my breaker over to the utility side of the A switch. Then we're going to switch to utility or solar, doesn't matter, and the power will come out on this black wire. And then we're going to take the wire that we pulled off of here, the refrigerator wire, and we're going to connect those up. So basically, you've got power coming off of your breaker going over to the transfer switch. The transfer switch also has solar, and then depending on whether you switch it to solar or utility, that power will come back out of the switch on this black wire, and we'll connect that up to the original wire going to the refrigerator. That's basically how it works. So let's go ahead and hook that one up. Okay, so we've got our A circuit done. The red wire is coming into the breaker. That gives power to the switch. And the black wire comes back over and goes into the original circuit for the refrigerator. That one's done. Let's do the rest of them. Okay, so I've got all the circuits wired up, all 6 of them. All the breakers are off and all the power's off. I'm just using a flashlight right now. So everything's hooked up, but I got everything off. I went ahead and plugged in the 30 amp cable into the inlet plug. That's the 1430 plug over here on the OUPES. So what we're gonna do now is, if this was a power outage, we come out here and turn on the power to the 6000. Then you come over here and hit the power button. Give it a second for the inverter to come on, and I've got a light hooked up to it too with that extension cord right there. That pops on, there you go. See, we're burning just 15 watts. And we're gonna go ahead and try our first circuit. So this would be the bedroom on the end of the house. Well, it's pulling 80 watts, so it must be doing something. Let's go have a look. Yep, there you go. First bedroom on. All right, let's turn on some more lights. That's everything. I'm gonna leave the refrigerator off because I don't want to cycle it. But oh, now we're pulling 350 watts, and everything in the house should be cranking. So we've got lots of circuits hooked up. We got lights where we need them, plugs and things, bathrooms, master bedroom, master bath, the microwave, the refrigerator, sort of the bare necessities. Okay, so my last test then is to turn on all of the utility power and make sure that there are no issues there. Okay, so now my backup circuits are still on solar, except for this one. I got the refrigerator on the utility, and these 5 are still on the solar power. So we're sharing the load of the house, and everything seems to be working just fine. So that's good. All right, let's talk a little bit about this plug section. So this unit uses an inverter off the battery to generate 240 volts. That's 2 legs of 120. Leg 1 is over here, 120 volts, leg 1. Leg 2 is over here, this is 120 volts on these 2 plugs. Now you put the leg 1 and leg 2 together and you get the 240 volts for these 2 outlets, or this one too, actually 3 outlets of 240. Now, there's a couple of important things about this. First of all, this section is backed up by UPS or EPS. So if you had a computer plugged in and the power goes out, it'll switch fast enough to keep your computer from crashing. This side is not backed up by UPS. The other important thing is the only way you get 240 volts is through the inverter off the battery. So if you try and do pass-through charging, which we all want to do, that means you're plugging it into a 120 volt outlet of your house on a 20 amp circuit. Well, when you plug that in, it shuts the inverter off and it passes that utility power directly through to whatever's plugged in on this side. So you'll no longer have the L2 because you're not inverting anymore. There are also two hard limits on that, and that is essentially the 20 amp circuit. So there's no way you could get 6,000 watts out anyway, because your circuit on your house has only got 20 amps. And the other thing is the cord. So if you tried to get 6,000 watts through that little cord, it would melt the cord. So the system's smart enough to know when you plug into the utility to do pass-through charging, it will only power this side, and it'll still limit the total amount of current through that cord. Say if it was using 1800 watts to charge the unit, then it would limit the output so you wouldn't go over the 20 amps. So let me show you how that would work. I'm going to go ahead and plug it in to the utility. Now, it might take a minute for it to recognize the utility power, and then should cut off the 240 circuit that's powering the house. Alright, so it just clicked on. It's starting to charge, and it did cut the 240 volt circuit. So you can see that when we're charging off the wall, we're passing that power through to the house now, but only on L1, because it can't do 240 because the inverter is off. It's passing that power through. All right, let's talk about an easy workaround to this pass-through charging dropout issue. So let's say you've been in a storm and your batteries are really low and you need to recharge it with a gas generator. So you've got like 240 volt inverter type generator with clean power coming out. Then you're going to go crank that up and plug in a 20 amp extension cord to recharge the OUPES. But as soon as you plug that in, it's going to drop out the 240 volt circuit. Well, that's no problem. You just take this guy off and plug this now directly into the generator, the gas generator outside. All right, so now the gas generator is powering the house, and it's charging the OUPES on the second 20 amp cord. So this is better than just running the gas generator 24/7, because you're saving a ton of money in gas, and they're loud and carbon monoxide and smelly and whatever, so you don't need all that. You're only going to run it for 2 hours, recharge this battery, and then you can switch them back. So, you know, easy workaround, and then OUPES doesn't have to add that whole 240 volt charging circuit and add all the cost to the machine. Simple workaround. All right, let's talk about bonding. In a 240 volt circuit, we've got two hot legs, and then we've got a common and a ground. If the common and the ground are tied together, that's called bonded. If they're not, that's called floating neutral. Now, in a typical house, you're only going to want to have bonding in one place, and that's at the main panel. So we'll tie the common and the ground together at the main panel, and then your system is bonded. You don't want it connected anywhere else. So when they sell these generators, solar or gas, they usually send them out with floating neutral. Okay, and that's because they expect you might come along later and connect through a transfer switch like we did, and that connects your common and ground and bonds you through the panel. This system is now bonded because it's connected through the transfer switch. Now, if you were standalone out in the field, you would be unbounded, floating neutral. You'd want to get a bonding plug that ties those together and ground your system. The way you can check to see if your system is bonded is use continuity. So if we have a connection, this thing's going to beep. So I go check this guy. That's unbounded, floating neutral. And then we go ahead and plug in through our transfer switch. And now they should be bonded. There you go. Okay, earlier I talked about charging my EV directly off the OUPES. Well, in standalone mode, it would be floating neutral, and the car charger is not going to like that. But when we go ahead and use the transfer switch and we get our bonding, now we're all properly bonded and grounded. So now my Tesla charger will be perfectly happy with that. Alright guys, so I know we covered a lot here, but the main takeaway I hope you'll get is that with the OUPES Guardian 6000 combined with that transfer switch, you can bring all that power directly into your house and power all of your critical loads. Now you can talk about adding solar panels and extra batteries and things like that, but this gives you a good base to work from, and they've got it on sale until Christmas for $1,700. And if you combine that with a 30% tax credit, you're down to about $1,200 on the Guardian 6000. Add $300 for that transfer switch, and you're at $1,500. Gives you a good solid base to work from. So it's a long video. If you stuck with me this long, thanks for watching, and I'll see you on the next one.